right, 10.1. So what we have here are exponential functions. So for something to be an exponential function, it's in the form y equals a times b raised to the x. So a is called the initial value, or the starting value. B is called your base. And then x is the exponent, and it has to be an x and an exponent for it to be an exponential function. So for the first questions, it says, which of the following are exponential functions? So this one here, yes, this is exponential because there's an x and an exponent. This is no because there's a 2 in the exponent, not an x. 3 is yes because there is an x in the exponent. 4 is no because there is not an x in the exponent. Then it says, what is the initial value in the base for those that are exponential functions? So the initial value is the number in the front. The base is the number under x. So this one here has a base of 3 because underneath the x is the base, and that number is a 3. The initial value here is actually a 1 because there is an invisible 1 in front of that 3. So initial value is 1. Okay, number 3. The base is 5 because there's a 5 underneath the x. The initial value is 2. Initial value is 2 because it's a number in the front. Easy. There is no initial or base for numbers 2 and number 4. Number 5, find the exact value of the function for the given x value without using a calculator. Easy. Y equals 3 times 5. I don't know why my dot's not working. Raised to the 0. Well, what we know is that anything to the 0 power is actually the number 1. 5 to the 0 is just 1. So this question is saying, what is 3 times 1? 3 times 1 is the number 3. Same with number 2. And by 2, I mean 6. So number 6, it says y equals 6 times 3 raised to the negative 2. 3 to the negative 2. 3 squared is 9. The negative puts it on the bottom of the fraction bar. So this is saying 6 times 1 over 9. 6 times 1 is 6 over 9 is my denominator. That reduces to 2 over 3. Okay, negative exponents turn into fractions. 3 squared is 9, so it's 1 over 9. Okay, 7 is a little crazy. Number 7, y equals 8 times 4 raised to the negative 3 halves. Okay. 4 raised to the negative 3 halves. It says don't use a calculator, but you're welcome to use a calculator to double check your work. So 4 raised to the negative 3 halves. That becomes 1/8. That's annoying. So this here is actually 1 over 8, and this is 8. The reason why is because 4 to the 3rd power, and then 4 divided by 4 squared would be 1 over 8. 8 times 1/8 is just the number positive 1. So number 7 is done. Number 8, use the property of exponents to solve each equation. Stop. Easy. Property of exponents means the base has to be same. So 2 to the x gets to stay 2 to the x. However, 4 doesn't get to be a 4. 4 is 2 squared because 2 squared is 4. There was a 2 up there, so that 2 has to stay there. Now, my bases will cancel because it's the same base. So that leaves me with an x. I'll write that better. That leaves me with x, an equal sign, and 2 times 2 is 4. So x equals 4. Okay, number 9. For these to have the same bases, they have to turn into 2's. 2 to the 3rd is 8 times x over 2 equals 4 is 2 squared. And up there was an x plus 1. Now the bases are the same, so they can cancel. 3 times x is 3x over 2. Distribute 2x plus 2. To solve for x, I'm first going to get rid of this fraction by timesing both sides by 2. Timesing, multiplying. So that leaves me with 3x equals 4x plus 2. No, plus 4. Solve for x, minus 4x, minus 4x. Negative 1x equals 4. X equals negative 4. Is the correct answer for number 9. 10, nice and easy. 9 is the same as 3 squared. There's an x up there. On the right side, it already has a base of 3. Because my bases are the same, they're going to cancel. That leaves me with 2x equals x plus 1. So x equals 1. Press pause on that original one if you needed that work. I'm going to erase this guy too so we can work down here. In fact, I'm going to erase the whole page. Okay, moving on. Number 11. Again, has to be the same base. 3 is good, stays there to the x. 3 to the third power is 27. There's no exponent here, so it's just 3 to the third. Bases are the same, so we can cancel. Set the exponents equal, so it's x equals 3. 12, very easy. Bases are the same, so they're going to cancel. So that leaves us with 2x minus 1 equals 4. Get x by itself. So x equals 5 over 2. 13. Bases are the same, so they'll cancel. A little bit more difficult. X squared plus 2x equals 3. To solve for x, there has to only be one x in the equation, so this is not regular solving. Because there's an x squared, it means we have to factor. The only way we can factor this is by moving everything to the left. Okay? So now to factor, I need to figure out what multiplies to make negative 3, but adds to make 2. Let's look. 1 times 3 with a negative 1 there. Negative 1 times 3 is negative 3. Negative 1 plus 3 is 2. So these are my factors. So that leaves me with x minus 1 and x plus 3 equals 0. Now we solve for x. So x equals 1. And x equals negative 3. So 0. Okay, 1 through 13. Next, number 14. Okay, describe how the transformation changes. So easy, super easy. Let me write you a key at the top. Maybe. I don't have much of a top. We'll put it right here. I'll give you an example. Okay, a number in the back moves it up or down. This one would be down 4. So back number moves it up or down. A number up here with your x moves it left or right. Left slash right. So in this one here, it's always the opposite of the sign when it's with the x. So this would go left 4. The only other curveball they could throw at you is if you make it a negative. If there's a negative right here, it's called a reflection over the y-axis. And if there's a negative in the front, that's called a reflection over the x-axis. Okay, so it's kind of like a parent function example. All right, number 1, 14, not 1. Numbers with the x. X is a liar. Opposite of the sign means right 3. 15 plus 4 on the back. Plus is positive, so it's up 4. 16, negative on your exponent. That's this rule right here. So that's a reflection over your y-axis. The reason why is because if the x was over here, and now the opposite x value would be over here, so it just reflected itself from this side of the y-axis to that side of the y-axis. That's why it's called reflect over y. Ooh, 17 is ugly. 17 is the same as saying 2 raised to the negative x plus 5, but x has to be by itself, so that's 2x minus 5. It's a little annoying. So we had to flip it because it was in the wrong way. X has to be first. And then a left-right change has to have x by itself. Negative times x is negative x. There it is, negative x. Negative times negative 5 is positive 5. There it was, positive 5. Okay, so this thing here is going to go to the right 5, but it's also going to reflect over the y. I didn't add this one. 18 is a negative, so that's again reflect over y. All of these reflect over y's. But there's a 2 there, so a 2 is called a horizontal because it's with x, it's horizontal. But everything with x is the opposite of what you would think. So this is actually called a horizontal compression, which is super weird. But when a number is with the x, it's the opposite of what you'd think. It's not a horizontal stretch like you would normally think. It has to be horizontal compression because the x is the opposite of what's normal. So 19 is exactly the same for the exponent. So the exponent makes it reflect over y, and it makes it a horizontal compression. There's also a negative in the front, and we said a negative in the front reflects this thing over the x. It's going to reflect over the x-axis. Okay, next page. Okay, number 20. State whether the function is exponential growth or exponential decay. Super easy. So the way that I would know this, exponential growth means that the base is the number that's underneath the x. If this number is bigger than 1, then that's called a growth. If this number is less than 1, 1/2 is less than 1, then it's called a decay. So for number 20, that is a growth because the base, the thing underneath the x, is a whole number, bigger than 1, so it's growth. 21 is written like a fraction. 1 over 2 point whatever is still a decay because that's still a fraction. 22.5 is the same as 1/2. 1/2 is a fraction, so this is a decay. Okay, 23. Okay, so to graph is a couple ways to do this. I'm going to show you a few. The easiest way, of course, is to grab your graphing calculator. So if you have one near you, you can grab it, and we can graph it in the calculator. But we're going to do a couple by hand. So do a couple by hand, and then I'll let you be lazy and plug it in. Okay, so the best way to graph a function is to pull some x's. The easiest x's are -1, 0, and 1. We plug those x's into the function 3 raised to the -1. What we know about a negative exponent is it makes this thing a fraction, 1 over. 3 to the first power is just 3. So when x is -1, the y value is 1/3. Next, 3 to the 0 power. Way back in the day, you learned that everything to the 0 power is always 1. Always, 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 always 1. Okay, last but not least, 3 to the first power is just the number 3. Now my graph. Left 1, up a third. Right none, up 1. Right 1, up 3. This function is going to look like this. Okay? Domain, as always, is all real numbers. My range is where my asymptote is. So let's get asymptote first. Asymptote is a y, so it's y equals. So this function is never dropping below this line. On this one, my asymptote is a 0. Hint, the number in the back of your function is your asymptote. For this one, my asymptote is 0 because there's nothing there. No number in the back of this equation. So now my range is always my asymptote in whichever direction it was going. So my y's live above the asymptote of 0. Okay, not too difficult. So let's try another one by hand, and then I'll let you plug them into y equals 24. Same thing, I pull the same ordered pairs and I plug them into my function. 3 raised to the negative 1 plus 2. Negative 1 plus 2 is 1. 3 to the first power is just the number 3. Next one. 3 raised to the 0 plus 2. Just taking my function, plugging in those x's. That makes 3 to the second power. 3 to the second power is 9. Next one. Base is 3. Next x value is a 1. Formula says plus 2. 3 to the 1 plus 2 is 3 to the third. 3 to the third is 27. So now I'm going to graph what I can. First ordered pair, left 1, up 1, 2, 3. Next ordered pair, 0, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9. Next one would be 1, comma, 27, which obviously won't fit. Because there's no number in the back of this, there's no plus or minus a number behind, it means that my asymptote is 0. Because this is like saying plus 0 in the back. So now I'm going to connect my dots, but I'm not going to let it fall below 0. As always, domain is all real hashtags, all real numbers. Asymptote, there's nothing in the back, so it's y equals 0. Range is the asymptote, it's opening up, so it's greater than 0. Okay? Okay, so next one here, let's play with calculator. Go to your calculator, press y equals. Type in negative 3 raised to the x minus 1, right click plus 2. Go to y equals, let's type that in. Negative 3 raised to the x minus 1 plus 2. Enter. Graph. So when you graph it, you'll see that, hey, look, there's an asymptote at 2. Because there's a number in the back, there's an asymptote there. Y equals 2. So now on my graph, it's going to be approximately 0 is there, and then it's like right between the 1 and the 2. And then it gets really close to that asymptote, and then it falls. So as always, my range is all real numbers. My range is the same as my asymptote, but this one is dropping down, so it's the less than sign. Okay, so we use y equals, type it in. press graph. You could have just made a table, plug in 1, -1, 0, and +1, and figured out the y values by calculating them. But you did that for the first two, so you can play with y equals. Move to 26. 26 is the same idea. I'll do 26 by hand only because they changed the base, so you can see this here. So doing it by hand means you make a table. -1, 0, 1. What does this line look like? I don't know. 1/3 raised to the -1. What we know about a negative exponent is it makes what its base is going to flip. So instead of 1/3, it becomes 3/1, which is just 3. -1/3 to the 0 power, we said everything to the 0 power, is always 1. Last but not least, 1/3 to the first power. Anything to the first power is itself. That's just 1/3. We've talked about asymptotes. It's the number in the back. We used to call that number the y-intercept. In this section, we call it the asymptote. There's nothing there, so my asymptote is 0. Now I can take my ordered pairs and graph left 1, up 3. 0, 1, 1, 1/3. Connect your dots. Range is always all real numbers. I'm sorry, domain is always all real numbers. Range is always your asymptote. All of my y values live above the asymptote, so it's above 0. 27, you can make a table or you can plug that in the calculator. I'm just going to plug it into y equals. Parentheses 1/3 raised to the x minus 3. So in this one, you should notice that there's a number in the back. That number in the back is called an asymptote. So what this graph does is it goes towards the asymptote just like this. Domain is always all real numbers. Asymptote, we just said, is -3 because it's the number in the back. Range is the same as the asymptote. All of the numbers are above -3, so it's greater than -3. 28. I'm going to use y equals. We could do it by hand, or we could plug it in and look at the graph. Raised to the x minus 2. In this one, there's no number in the back, so you should immediately know that I have an asymptote at 0. There's nothing back there. So I can draw the fact that this goes from 0. This line, you could always do control table or second table and see exactly where these are. So in this one here at +1, my y coordinate is -3. At 0, it's like -9. At 2, it's -1. It's going to go something like this. As always, domain is all real numbers. My range is y. They all live below the asymptote, so my range is that they all live less than 0. All of my points are underneath 0. Okay, a couple more. Now we roll into e. E is my natural log function. It's the inverse of a natural log, which we'll talk more about that soon. So I'm going to do the first one by hand. We'll do the first two by hand, then we'll use the calculator. As always, whenever we make a table, it's an x, y, -1, 0, and 1. So I'm going to take e and I'm going to raise it to the -1. In your calculator, you can press second ln, that's the number e, raise to -1, and you're going to get that that is 0.36. Those are numbers we memorized last year in Algebra 2. Next one, e raised to the 0 power. What do we know about 0? The answer is always 1. E to the 0 is just 1. Last but not least, e to the first power. is always the number 2.7. Okay, so these are actually your parent function numbers for e, so that's helpful. This is the parent function for e, so it's 2.7. To graph, I'm going to go left 1 and up 0.36, 0, 1, 1, 2.7. No number in the back, so again, asymptote is at 0. Connect your dots, go close to your asymptote, and you have a line. Domain is always all real numbers. Range is always your asymptote. They all live above 0, so it's greater than 0. So now for 30, you have two options. You can take this parent function and shift it according to that. You could plug it into y equals and see what it looks like. So let's shift from the parent function. That's actually going to be the easiest. Okay, so what I know is that a number with the x affects the x-axis. X plus 3 actually means we're going to subtract 3 from our x's. -1 subtract 3 is -4. 0 subtract 3 is -3. 1 subtract 3 is -2. These are the x's that I'm going to have to graph. Now it says that there's a y change. It says take your y values and subtract 1. So I'm going to subtract 1 from each of these y values. 0.36 minus 1 is -0.64. 1 minus 1 is 0. 2.7 minus 1 is 0.7. So I took my parent function, which was e to the x, and I shifted the x's to the left 3, and I shifted the y values down 1. Now I can graph. This thing goes left 4 and down 0.64. Left 3, 0. Left 2, 0.7. Asymptote is the number in the back, so there's an asymptote. Oops, that's not right. There's an asymptote at -1, which means my line is going to look like this. So it was this original parent function, but it shifted to the left 3, and it shifted down 1. My domain is always going to be all real numbers. My range, well, my asymptote is -1, which means my range is that all of my numbers live above the number -1. Last but not least, 31, we'll do the same thing by hand. I'm going to take my parent function of e, which is -1, 0, 1, 0.36, 1, 2.7. I'm going to change, I don't have any x changes actually. The x is by itself, so that's good. But it says take the y values and make them negative. So it's -0.36, -1, and -2.7. And it says take those y values and add 2. So -0.36 plus 2 is 1.64. -1 plus 2 is 1. -2.7 plus 2 is 0.7. So I don't need these y values. I took the original, I multiplied times the negative, and I added 2. So now I'm going to graph this line. -1, 1.64, this video is about to end. 0, 1, 1, this is up here. My video's gonna end. -1, 1.64, 0, 1, 1.7. Line. Asymptote. Oh, shit. Asymptote is +2. So my line's going to go like this. Domain is always all real numbers. Asymptote is the number in the back. Range is everything lives below 2. Okay? Look for the second video to get through the rest of this worksheet.